Here we go. Okay, here's our first problem that we have to solve for the course. First problem, kids, we're diving in. Now pay attention. I guarantee you will see one like this on your first academic adventure. All right, there's the problem on the board. Here it is. How much heat to get 1 kilogram of ice, which just came out of the freezer at -10. Ice coming out of the freezer is not zero. If you had your freezer set to 0, you'd have mushy ice cream, okay? When you click it like the 5, 6, it's below 0. It's cold. It's like cold, cold, cold. -10 Celsius. So we want to get this -10-degree block of ice you just took out of the freezer. 1 kilogram is like you take your 1-liter water bottle and freeze it. It's frozen, been sitting in there for a while, -10, cold. Take it out. Now you want to get that to boil. Not only just boil, but vaporize, completely vaporize at 100 degrees Celsius. How much energy would it take to do that? How much heat? That's our job. Here's how we do it. I call this bookkeeping. Organize. You stay organized, you will get this problem. Okay, here's what we do. And I always draw a picture of it. I draw a picture to show how this is going to work and how we're going to solve the problem. Here is my ice. It's at -10 degrees Celsius. What's the first thing that's going to happen when we take it out of the freezer? You're going to put it into a pot it's going to be eventually a pot that's going to hold the melted ice. You're going to boil. You're going to boil it, right? So you need to put it on the stove. So take it out, put it in a pot. What's the first thing it's going to do? It's going to melt right away. No, it won't. It won't melt right away. It can't melt right away. It's at -10. Ah, I hate this class. That was the angsty Billy coming out, okay? That's what happened. It's got to get to 0 before it melts, right? Let's draw that. So here's time going this way, and here's temperature going up, a time versus temperature drawing. So the ice has got to go up to 0 before it begins to melt. So it goes up to 0, then it melts. So the temperature, as time goes on, is going to go boop, 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 boop. The ice goes up in temperature. When it gets to 0, now it starts to melt. During a phase change, this is important. This is important. During a phase change, there is no change in temperature of the substance. So we are now going to melt at 0. Notice as time goes on, my temperature is not rising. During a phase change, I repeat it one more time, you get no change in temperature of a material. Why? What's going on? I mean, we've got this on the stove now. We crank the stove up. Okay, it should be, it should be going up in temperature. Not until it melts, because what's going to happen is the energy you're putting into it is going into bond breaking. You have to break the bond. Bond, I must break you. I will never break. I am a Secret Service agent of the Queen. A bond you must break. Right? You have got to break the bonds. Cause that crystal structure to break down and go into the liquid. Liquid, yes, liquid. So the energy goes into bond breaking, into crystal destruction first. Now, after we break the bonds, we break the crystal structure, and it takes some time to do